Now, you have the floor.
Okay. Yeah. One of the reasons that I've seen issues with the scientific community trying to talk about cosmology is, yes, they're grounded in deductive reasoning, which works great if you're trying to
Explain deductive.
Explain something like, deductive means you're taking measurements. You check the wavelengths coming from a star, so you can tell what color it is, what temperature it is, how big it is, how much mass it has. But if you're looking at the totality of the universe, whenever you're looking at something deductively, you're looking at it from outside. And that's the only way you can actually do deductive logic. So the question is, well, how do you talk about the universe? You can't get outside of it. There is no outside of the universe. So deductive reasoning doesn't work. You're inside the system. So the only way you can actually figure something out is inductively. Now, inductive reasoning, unlike deductive reasoning, it isn't 100% perfect. So the only thing you can do is exhaustively try it over and over and over. And every example you find that's true and that it fits, your theory becomes more powerful. And yes, if you find an exception, you have a big issue. To date, we haven't found any. We've found that we can apply this theory from a microscopic level down to quantum physics up to astrophysics and large heavenly bodies. The theory doesn't change, and it solves the problems, even human life. And the other problem is with science, when they do deductive logic, as I said before, part of what we do and we're allowed to do using philosophy is qualitative analysis, and that's something science just can't do. It's just not possible. I can do a lot deductively. I can tell you how much mass an orange has, and what chemicals are inside it, but it doesn't describe how it feels or it tastes, and those are very real things. Whether they're quantifiable or not, you can't deny the fact they exist. And there's a similar issue when you look at things like awareness and consciousness. For one, we've proven in quantum physics, actually being able to observe can change something in the real world. By your simple act of looking at it, you've actually made a change to the physical world. And I'd also argue that whereas physicists would say, well, emotion's not part of the universe, it's not tangible, I can't touch it, I can't measure it, so it doesn't count. But we know day to day that obviously emotion does actually have a real physical impact that is indirectly measurable. I go by the store. It's my wife's birthday, so I get her flowers. I've made a purchase and I've moved an object there based solely on emotion. So I've made a change in the physical world just by having a thought that's purely emotion driven. There's no point in doing it, yet there was actually a change in the universe. So discounting emotion is not part of the universe. It is just incorrect. And the reason physics does it is it's just not in their toolbox. They have no way to measure it, so they just ignore it.
I think you're very eloquent. I think you're very eloquent in your presentation. No, seriously. Explain to me more. You've looked at Summa theory, aka potentialism theory, over decades. Tell us more how your experience with checking it out inductively. Tell the audience and me more about it.
Okay. Yeah, and let's start at the beginning. The Big Bang's actually a very good point to start at. I guess right after the zero point,
right.
When the universe came to be. If we're looking for one rule that's actually eternal, what can you have before nothing? It's not like, and you have to understand that when the universe, before the universe came into being, there was an empty space, and that's a common misconception. People think that there's just this vast darkness. There is no space, literally. Until the Big Bang actually occurred.
Create space.
Yeah. So the question is, well, what's eternal then? What could possibly be a drive? Well, the only thing that comes before something is the potential for it to be. There's just rationally nowhere else to go from there. So that's an excellent start if you're looking at potential theory. It's the only thing that you can truly say predates our entire universe. Whether you wish to call that God, whether it has a self-awareness and a consciousness, that's really not for us to decide. But the simple fact that potential existed is inarguable. there can't be anything before there's a possibility it could be.
Just for definition, or how I define things, for the sake of clarity in my treatise, I call the universe, the physical universe, post Big Bang, and everything else I call, all inclusive, I call the cosmic order. So first, there is a cosmic order that's generally accepted, and post Big Bang, there is a universe. And the audience should be aware that the universe keeps building out. It grabs from the void. The universe is continuously, as we speak, expanding and grabbing, creating something from almost nothing, as we speak. People should be aware of that. Okay. I think the concept of zero is very profound. And down the road, researchers can look at that whole situation better. Let's shift gears a little bit and maybe articulate some of your, well, first I want to say, to be clear, metaphysics and a framing theory must, as a prerequisite, stand up against all scientific theory. But it has to take it much further than that. It's not as if the two are separate. Metaphysics wraps around scientific theory. So the fact that scientific theory can't handle something doesn't mean that we can ignore it. Any metaphysics must comport to existing scientific theory and take it much further, metaphysically, into the softer realms. Science is great. We love science. We need science. But science has limitations as to what, by its own definition, can be measured. And the scientists cannot be allowed to become the priesthood for metaphysics. That's not their turf. And almost by definition, they're wired against that turf. Now, back to randomness theory, my favorite punching bag. Talk to us about how it breaks down inductively. Okay, get us rolling on that. How does it break down?
Yeah, well, for randomness theory, actually its biggest problem is randomness theory doesn't work with religion. So anything that sounds remotely like spirituality or religiosity, it pokes a hole in the theory, because their entire theory is that the universe is just breaking down and falling apart, and it's just a big pile of chaos.
Right, but maybe religion and spirituality are wrong. Mm-hmm. So they're wrong. Yeah. How does randomness theory break down if religion and spirituality are wrong? Yeah. How does it break down independently of whether or not religion and spirituality are in the mix?
Seth Lloyd's actually a very good example, in that Seth Lloyd looks at his model of the universe as what he calls a supercomputer, and the fact that that particles do tend to break down means there's more of them, which means if you count every piece of matter that exists in the universe and the energy, the more it actually breaks apart and expands, the more bits of information it can actually store, which means it's growing in complexity and becoming more than it was, which is in direct conflict with randomness theory. Randomness theory is largely based on a law of thermodynamics.
An alleged law.
Yeah.
An alleged law
Yeah.
of thermodynamics, right?
Yeah, that's
An
true.
alleged law, right?
Yeah.
Right.
Yeah, where heat only dissipates and expands, and doesn't come together. There's examples everywhere where this isn't actually true.
Right.
But they always they play that off as saying, "Oh, well, that's short term. It'll happen eventually." Right. Yeah. So Lloyd, on the other hand, says, "Well, it's growing in complexity, and which is in violation of theirs, because they're only basing it on a thermodynamic law, how the entire cosmos
Alleged
works."
law. Alleged law.
Yeah.
Which they created in the first place.
Yeah, and another funny thing is, there's no reason to think the laws that we go by in the universe are set in stone yet. They've changed before.
Well, okay. remember, I don't want to contradict what we're also saying simultaneously. Metaphysics has to comport with tough science. And that means with core science. If there are, it cannot comport with what the randomness people say is science when they take science beyond where it wants to go. For instance, the second law of thermodynamics discusses closed systems. But the randomness people conveniently disregard the fact that they have to operate in closed systems. Okay, so one has to be careful. Metaphysics must comport with hard science, but it doesn't have to comport with amateur science, which is where typically, God bless them, the priesthood, the atheist priesthood connected with randomness theory often goes. They go beyond hard science into very specious interpretations of theory. Okay, but randomness theory, what you're articulating is perhaps not that clear to comprehend. I touched on the issue in the prior text. Randomness theory is built on sleight of hand, basically. Wherever you are now, look at the people in the room. All these people had to evolve by accident, randomly. The universe, the weather, the stars, the heavens, gravity, love, history, all had to just conveniently come together. Millions and trillions of coincidences, and to all keep rocking and rolling by some accident of fluke of probability. Would you bet your entire existence on that theory? I don't think so. The Vegas gamblers would not put too much odds on that theory. It sounds like the mirror image of fundamentalist religious theory. Well, this is the way it is, and this is the way it always was, and don't disagree with us, and don't ask too many questions. These things do not work, and the randomness people position it as science, but it's basically fundamentalist anti-religion. It's the mirror opposite, and it's a movement which brooks no dissent and even no discussion. They all award each other prizes. This prize, 2016, the Committee of Randomness Atheists awards the prize to one of their fellow randomness atheists. And they're all happy. And they go to their graves happy. But unfortunately, history will mock them. You can quote me. I think that'll conclude on that high note. We'll conclude this portion, and we'll continue in a few minutes.